Okay, let's keep going. You guys are so happy and excited and loud. Okay, we're going to do, I forgot, I went and erased it. So we're going to do a quick practice problem based on the dart. All right, so let's go back and say that dart, and you're going to calculate it, and then everybody's going to get it wrong. We'll talk about why. That's what's going to happen. Okay, here we go. Just to build up your confidence, I'll tell you that. Okay, so let's say it was a 100-gram dart. Okay, and it was going at 15 meters per second here. No, I'm sorry. Oh, crud, I changed the numbers 5 times. It was going 15 meters per second, very fast, right, at the ball. And then it bounces back I had it drop down to 8 meters per second, right? So let's calculate what is J. See if you can calculate J in that case. Boom, boom. The whole thing for you there. Yes, F. It must be the mass. How many, wait, hold on. How many got 0.7 kilogram meters per second? Not quite. Yes, because you forgot that momentum is a vector. This is the most common mistake in momentum problems. That's why I made you do it and asked you to raise your hand. How many, let's see, so don't forget, I'm trying to decide if I'm going to write this here. Let's write this here. Don't forget that P with an arrow over it is a vector. Okay? So I'm sure many more people than raised their hand got 0.7. Because you said what we've been saying is J is M times delta V, and delta V is 15 minus 8. Right? But it isn't. We had a bigger change in 15 minus 8. We were going forward 15, and we came back 8. So the difference is 23, right? So let's look at that in detail. What I mean is let's remember that this thing, well, here's the V. V initial was 15 meters per second, say I hat, if we wanted to write it in detail. And V final was minus 8 meters per second J hat, right? If we wanted to put it on an axis and do it correctly. And then we know that J vector, let's say in the x direction, so we're doing one dimension in the x direction, equals what? It's equal to delta P in the x direction. We don't need the x's, it's one dimensional. Right? So the vector J is equal to the vector delta P. So that's a good question. At the break, what are they the same? So can I say an object has impulse momentum? No, so they're not exactly the same in that sense. The impulse is only the same as the change in the momentum. It's not the same as the value of the amount of momentum. It's the change over some process, right? So like how much money you have is in dollars, and if you have a transaction, that's also in dollars. So how much money you have is how much money you have. The transaction is how much your money changes. So that's the sense in which they're the same and they have the same unit, but they're not really exactly the same. This one is a change. So J is delta P, so we would say, okay, what is that equal to? Then how do we get delta P? Well, it's P final minus P initial, right? Changes are always final minus initial, right, with a negative sign, right? Subtract P final minus P initial, okay? But then, to do a problem, often then we go to magnitudes, and then we put in the negative sign, right? When I said 8 right here, that's a magnitude. It has to be a magnitude, it's a number. The number 8 is not negative 8, it's 8. And you could say I put the negative sign in front of the magnitude to tell me it's going left. Or you could say the component equals negative 8. You can interpret that either way. So we go to plug in here, we'd say P final, we could say it's the magnitude 15 and it's positive because it's going to the right, plus 15 meters per second. Right? Or you could say the component of the vector is plus 15. But then this minus is not saying it's going the other way. That minus is because it's a difference. So that minus has to be there. Right? This is the difference minus. You can have a change in momentum and go forward and not have these two be opposite directions. Remember Sint? She was going forward and she went forward faster. So both of her velocities were positive. Yeah. Oh, did I go backwards? No, it's slowed down. Yeah, 8 is final. 50, oh yeah, I just said the wrong number. Wait, final minus initial. Yeah, sorry, so I wrote these backwards. Final final minus initial. So my notes are backwards. So final is minus 8, right? So we all agree, I could either say that's the vector component, thank you, that's the vector component is minus 8, or I could say it's negative and the magnitude is 8. Why is 8 meters per second j hat, not I hat? Okay, so I've just totally blown this all over the place. Wow, I have them in different dimensions. Oh my God, okay. Well, this is actually what happened when it took a 90-degree turn and almost hit the guy, right? So it did actually go from my head to j hat. But anyway, I was just trying to be real, you know, okay. Let's start over. Let's start over. A simple one-dimensional problem. The bullet went forward at 8 meters per second in the x direction, so it's, I'm sorry. Okay, let's start over. The bullet went forward at 15 meters per second in the x direction, therefore that is plus 15 I hat. And it bounced straight back at 8 meters per second backwards, also in the x direction, also, so it's also I hat, but we put a negative sign on it. Okay, delta P is final minus initial, so the final momentum was negative 8 meters per second, right? We got to multiply by the mass, right? So negative 8 meters per second times the mass, which was the mass, did we give you the mass 100 grams, 0.1 kilograms I hat. I'm really just trying to illustrate the negative sign. And then this is what I'm trying to say. This negative is not because it bounced the other way or initially started the other way. That is just due to the definition of a difference, right? Difference is final minus initial. So now we put in this speed, 15 meters per second. Magnitude, it's positive. So we can say minus positive 15 meters per second. We've got to multiply it by the magnitude, or by the mass, kilograms. And then that's also in the I hat direction. Okay. So you can see this is how we ended up using 23. So it's actually negative, I should have said. I didn't define the positive direction yet. Oh, yeah, I did. So this is 8 minus 15, negative 23 times 0.1, minus 2.3 kilogram meters per second, also I hat. Right? Okay, so unfortunately I sort of flubbed that in the middle and maybe confused you worse, but if you got 0.7, think about why it's 2.3. It's because often in collision problems things change direction, but not always. Okay? Think about Scent getting hit from behind by the avalanche. All it did was speed her up. She didn't have a change in direction. So you don't have to have a change in direction.